Hello and welcome to video 4 of my ISM project series. If you haven't watched the prior 3 videos, please go ahead and watch them. They provide some important context for this video. An overview of this video. So in this video, I'm going to introduce particle functions and the concept of probability. So particle functions, what are they? So basically what they are is that they are a way to represent particles. And we see an example right there. So an example, let's say we have electron beam, and it's represented by its components of spin up and spin down, and it's denoted by the ket by the symbol of psi on the left hand side of the equation. And these particle functions are usually described using a ket vector on the left hand side of the equation, and the coefficients of the spin up and spin down ket vectors when they're squared and added to each other must equal 1. And the going on to probability, inner product is a core concept for probability. It's just essentially the multiplication of bra and ket vectors, as you can see in the image. It's just matrix multiplication. So on to probability. So the given image is like a postulate for probability in quantum mechanics. So what it basically is the absolute value squared of the inner product, as I showed in the previous slide. So once you multiply the bra and ket vectors, take the absolute value of that and you square it. And then that gives you the probability of a given spin measurement. And we'll go over an example. So on to the example. I have rewritten the equation for probability on top and a example equation down below. So given the electron beam denoted by the ket vector psi as 1 over square root 2 spin up plus 1 over square root 2 spin down. What this specific setup is trying to ask us is, what is the probability of finding spin up in this specific equation, part equation here? Well, what we can do is utilize this entire equation here. So if we remember back to the previous video, what the bra vector, the spin up bra vector looked like, it was this. Oh, my bad. Its matrix was 1, 0. But how do we multiply these two matrices? This obviously does not look like a matrix. So one might say the inner product is impossible. We can't find it. But I want you to think about what the spin up ket vector and spin down ket vector can be represented as. They can be represented as matrices as well, as 1, 0, and 0, 1. So by substituting the matrices that these ket vectors symbolize, we can convert this particle function into a matrix. So by just doing simple multiplication, we get times the spin up ket vector, 1, 0, plus 1 over square root 2, the spin down ket vector, 0, 1. And by multiplying this, we can get 1 over square root 2, 0, plus 1 over, no, my bad, 0 over 1 over square root 2. And remember, you're multiplying a scalar times a vector. You just multiply the constant by each of the terms in the vector. And that equals the psi ket vector. And then adding these two vectors together, we just get psi is equal to 1 over square root 2, 1 over square root 2. So that was successful. We have successfully represented this function as a matrix. So now we can go on with the inner product. So the inner product, in this case, is this. So by substituting the spin up raw vector with its vector counterpart, and the psi ket vector with this matrices, my bad. We can get the result 1 over square root 2. And I will go over the steps briefly. So since this is a my bad. 1 row by 2 column vector, and this is a 2 rows and 1 column vector, matrices, my bad. We see that the columns of the first matrices match up with the rows of the second matrices. And the resultant matrix will be given as 1 row and 1 column, right here. So by multiplying 1 times 1 over square root 2 and adding that to 0 times 1 over square root 2, we can get 1 over square root 2. So 1 times 1 over square root 2 plus 0 times 1 over square root 2. Don't know why that came so long, but okay. So we have this value here. But what do we do with it? So we go back to equation. To find the probability of finding a spin up particle in this electron beam, we just have to take the absolute value and square it, since we already completed the inner product. So the absolute value of 1 over square root 2 is just 1 over square root 2. And then if we just square that, we get 1 squared over square root 2 squared, which is just 1 over 2. So what does this 1 over 2 signify? What does it signify? So we were trying to find the spin up probability, the probability that a particle will spin up in this electron beam. So we can write it like this: probability that the spin will be equal to plus h bar over 2. So this h bar over 2, right? In the first spin video, we talked about how spin up for an electron was given as plus h bar over 2. So I'm just going back and using this to represent spin up. The probability of spin being equal to plus h bar over 2, or p of being spin up, is equal to 1/2. So which means that half the time when you measure the particle beam, you'll get a result that is spin up. Another half, you'll get it spin down. Why? Because we see up here, the only things we have are just spin up and spin down. So now I'll give a different example, something that is a bit more trickier. So remember how I said that the coefficients of the equation have to add up to 1, we can alter the values of the coefficients and make it so that um, spin up happens more often or spin down happens more often. Here, here an example. So we have a function psi. We have, let's say, 3 over 5 spin up and plus 4 over 5 spin down. So using the probability equation, let's find the probability of this particle being spin down. So P spin down equals what? So let us set up our probability equation. Absolute value of spin down times the psi vector squared. So we know that this bra vector is the same as 0, 1. 0, 1. And that, but now the psi ket changed. Instead of being 1 over square root 2 over 1 over square root 2 matrix, we have different coefficients. So we need to find the new matrix for the psi ket vector. So my bad. So replacing the spin up ket vector and spin down ket vector with their matrix counterparts, we get 3/5 times 1, 0 plus 4/5 times 0, 1. Multiplying out, we get 3/5 0 plus 0, 4/5. Which then that just equals psi as 3/5, 4/5. So now we have the matrix for psi and the matrix for spin down. So now going on with the inner product. So 0, 1 times 3/5, 4/5. So 0 times 3/5. I only need a different color. My bad. So no. So 0 times 3/5 is 0. Plus 1 times 4/5, which is 4/5. So we get our inner product as 4/5. So now to find the probability of finding a particle spin down, we just need to take the absolute value and square it. So the absolute value of 4/5 equals 4/5. And then when we square that, we get 16/25. So we find that the probability of finding a particle spin down in this particular function of psi here equals 16/25. which can just be simplified down to uh, actually no, it can't be simplified. That's my bad. So this would be the probability of finding a particle spin down in this particular equation. And as you can see, it's not 1/2, which means that the probability of finding a particle spin down is actually greater in this situation than in the other equation, where it was just 1/2, 1/2 for each possibility. We see here that we have 16/25 probability of finding a particle spin down and a 9/25 probability of finding it spin up. So to calculate the percentage of that, we have 64% is the probability of finding this a particle spin down in this situation. So we can rewrite this as spin down 64%, which must mean that the probability of finding a particle spin up is 36%. And here you can see that the probability of finding a particle spin down is higher than finding it spin up. That concludes the video, and thank you for watching the video. Please complete the questions that come after the video. Thank you.